Go. Hi, my name is Lisa, and I'm going to be talking with Cheryl today about the conduction system of the heart. First, we're going to talk a little bit about the anatomy of the heart and a little bit about the blood flow of the heart, just so you get a general idea of where things are coming from and where they're going. Okay, so now we're going to start talking a little bit about the anatomy of the heart. First, we have our superior and inferior vena cava. We have our right atrium, and we have a valve here that separates the right atrium. It's going to be the tricuspid valve into the right ventricle. We have our pulmonic valve here. We have our pulmonary artery. Okay, so here we have the pulmonary veins. We have our left atrium. We have our mitral valve that separates the left atrium from the left ventricle, otherwise known as the bicuspid valve or the atrioventricular valve. We have our aortic valve, and we have our aorta. All right, so now we're going to start talking a little bit about the blood flow. Blood flow starts from your superior and inferior vena cava, and that's going to feed into your right atrium. Then you still have your tricuspid valve. It's going to flow into your right ventricle, through your pulmonic valve, through your pulmonary artery, and out to the lungs. From your lungs, it's going to come back in through your pulmonary veins, into your left atrium, through the mitral valve, into your left ventricle. From there, it's going to go through your aortic valve, through your aorta, and out to the body. Okay, so now that we've talked a little bit about the anatomy of the heart and the blood flow, we're going to start talking about the conduction system. The conduction system is composed of 5 different parts, and we're going to mainly focus on 2 parts today. But for what I have is going to be the SA node, the AV node, the bundle of His, the bundle branches, and the Purkinje fiber. Okay, so now we're going to start with the cardiac conduction system. It's a group of specialized tissue cells that send electrical impulses through the myocardium, which begins at the SA node, or the sinoatrial node, that acts as the natural pacemaker of the heart, keeps the heart rate between 60 and 100 beats per minute, usually. It's the strongest cell. There are other cells, but they are weaker, and they could be causing arrhythmias such as atrial fibrillation, atrial flutter, or supraventricular tachycardia. Okay, so from the SA node, it's going to send an electrical impulse through the atrium and allow for the atrium to contract. And it's going to go to the AV node that's located right under the atrium in the middle above the septum, where it's going to wait for the atria to completely contract before moving on to the AV bundle, the bundle branches, and the Purkinje fiber. Okay, so from the SA node, it's going to send an electrical impulse through the atrium and allow for the atrium to contract. And it's going to go to the AV node that's located right under the atrium in the middle above the septum, where it's going to wait for the atria to completely contract before moving on to the AV bundle, the bundle branches, and the Purkinje fiber. Okay, so from the SA node, it's going to send an electrical impulse through the atrium and allow for the atrium to contract. And it's going to go to the AV node that's located right under the atrium in the middle above the septum, where it's going to wait for the atria to completely contract before moving on to the AV bundle, the bundle branches, and the Purkinje fiber. Okay, so from the SA node, it's going to send an electrical impulse through the atrium and allow for the atrium to contract. And it's going to go to the AV node that's located right under the atrium in the middle above the septum, where it's going to wait for the atria to completely contract before moving on to the AV bundle, the bundle branches, and the Purkinje fiber. Okay, so from the SA node, it's going to send an electrical impulse through the atrium and allow for the atrium to contract. And it's going to go to the AV node that's located right under the atrium in the middle above the septum, where it's going to wait for the atria to completely contract before moving on to the AV bundle, the bundle branches, and the Purkinje. The measurement of the electrical activity through the heart is measured by an EKG or an electrocardiogram. Okay, so the first part of your EKG is going to be your P wave. Here, this is going to be your first little bump before everything else occurs. it represents atrial depolarization, and that's where the atria are contracting and squeezing the blood out into the ventricles. Talk about our next complex, which is going to be our QRS complex, and that is representation of your ventricle depolarization, and it's a much larger complex due to the strength of your ventricles, and that's where the ventricles are contracting. So now we're going to talk about our T wave. Our T wave represents ventricular repolarization, and that's the electrical activity that's left over after your ventricles and everything have squeezed. And that's going to start your next.
Thank you, Miss Lisa. I'm Miss Cheryl, and I'm here with
Alexa, Obi, Lori,
Shannon.
and these are some friends that I have, and we're going to talk about the conduction train system. Now, let's talk about the second half of our journey on the train. This helps signal the ventricles and other necessary parts of the heart. Well, we're headed down to Bundle of His on Bundle Branch Boulevard. As we leave the 80 Avenue station, we hit our next destination, which, just like I said, is Bundle Branch Boulevard. This is located at the bottom end of the septum, which is right in here. The septum is the bone that's in the middle of your chest, and that's where this is located. Well, Kobe, thank you. It's a directional spot. It directs the impulses and it helps them show which way they're going to go in the heart. The bundle branch splits the impulses at the station into left and right, where it travels up the branches on both sides of the heart at the same time, causing a rhythmic and coordinated effort. No, let me explain a little more about the Bundle Branch Boulevard. It takes the signal from the SA node where it started up here, travels all the way down. It's a very forceful impulse because it has to have enough force to send all the blood that's in here back up through the top part of the heart where it can go out. So this is a very important spot. Yes, our last stop is also very important. It's the Purkinje Fiber Parkway. It's located in the inner ventricular walls, which is inside the lower half of the chamber.
what does it do?
The fibers cause the lower chambers of the heart to contract rhythmically and coordinatedly, which causes your heart to go love dove. When you check your pulse and you hear your heartbeat, that's what you hear. And this is what causes that, because everything has to work together. It has to be rhythmic and it has to be coordinated. But the impulse has to be very strong because you have a lot of blood coming down into these chambers. And in order to get the blood back up, we have to force it back up. And this is a very strong impulse here to get this blood to go back up and circulate outside the body.
What happens there?
The fibers cause the impulse to contract very strongly. It goes on both sides of the heart. So we'll go from here, so it'll go up, force the blood up here and out. And then once it does that, it does it all over again. Yes, Toby?
What is that?
This is an EKG. When we talk about the ventricles, which is the lower part of your heart, we have to have some way to measure it when we test for problems with your heart. So when we look at the ventricles, we're going to look at the QRS signal. This is how your ventricles are relaxing when you're on an EKG. This is the whole thing. This is what your heartbeat looks like on a whole EKG strip. But since I'm talking about the ventricles, this is what we're looking at right here. And if we were to isolate it to see if you had some problems with your ventricles relaxing and contracting, we would isolate the signal, and this is what it would look like. So what I've done is I've given you 3 ways to remember the conduction system. We have SA, AV, BB, and PF, if you can remember it by initials. I also did the diagram so you can remember where everything's located. And here's an acronym to help you remember. SAVE, BP, SAAV, Bundle Branch, Purkinje Fibers. Thank you for being here today. What did we learn about? And what is this? What is this whole system here? The